Hello everyone. Okay, so in this video we're looking at increasing and decreasing functions. So we're going to be using calculus to be able to determine where a function is increasing and decreasing. But first, let's just quickly look at the relationship between the two. So if I open up GeoGebra here, so this is the graph of a polynomial of 4, whatever, right? This purple line here represents my tangent line. So look what happens now when I'm moving my tangent line along the graph, right? The slope is changing. We see here my slope is negative because my graph is pointing downwards. Then my tangent line becomes positive because now it's pointing upwards, right? So how can we use this to determine where a function is increasing and decreasing? Well, what we can say here is, right? Well, if you see here, my tangent line is pointing downwards, that means its slope is negative. So if we look here, my function is decreasing. Whee, decreasing, then woo, increasing, woo, decreasing again, right? So what we can say is, if the first derivative is negative, i.e. the slope of the tangent line is negative, my function is decreasing. And then if it's positive, it's increasing. So that is what we can say there. Let's go back here. So what we can say is a function is increasing if the first derivative is greater than 0. And we say a function is decreasing if the first derivative is less than 0. So for what values of x is this function increasing? So find my first derivative. That is equal to 3x squared minus 2x minus 8. And I want to find where it's increasing, so greater than 0. So now I have an algebraic inequality. So I need to factorize this. I think it'll be 3x here, x here. Please let it equal 0. Minus 2 plus 4. So that's factorized. So 3x equals minus 4. X is equal to minus 4 over 3. And then x is equal to 2. So my function is increasing. So we're looking at where it's greater than 0. So my values are not trapped. Therefore, this is 2. This is minus 4 over 3. And we can say if x is less than minus 4 over 3 and x is greater than 2. That is where my function is increasing. Right? Now, sometimes we're asked to prove... Sometimes we're asked to prove if a function's always increasing or always decreasing. So, prove that the curve y equals minus 2x cubed plus 6x squared minus 6x plus 5 is decreasing for all values. To prove that the function is always decreasing, we need to show that dy dx is always going to be less than 0. So we're proving, right? So let's find dy dx. That is going to be equal to minus 6x plus 12x minus 6. I notice here, and I want to find less than 0. I can factor out a minus 6, and that's the squared there. Now I'm left with x squared plus 2x plus 1. So not minus, so minus 2x plus 1. This is actually a perfect square. So it's going to be x minus 1 squared is less than 0. And that is true, right? So now I need to kind of comment on it. Well, I know this will always be positive, right? X minus 1 squared will be positive because anything squared is positive. But then I'm multiplying it by a minus number. So minus by a positive is a negative number. So what I can say is x minus 1 squared will always be positive then multiplied by a negative, therefore always negative, or i.e. always decreasing. All right, so let's do some exam questions here really quick. So this is a nasty looking one, but it's actually not too bad. So 2018 show that f of x is decreasing at point 3. So I need to find my first derivative, evaluate at x equals to 1, and show that it's decreasing. So, right, this one looks scary, but actually this is all a constant, right? So I just need to differentiate this e to the power of minus a half x squared. So if I just leave that out here, 1 over root 2 pi, then I'm multiplying that by the derivative of the power. So 2 in front here will just be times minus x, I believe. So 2 times minus a half is minus 1 to increase the power by 1. And then we're going to have e to the power of minus a half x squared. So I have here minus x over root 2 pi e to the power of minus a half x squared. Evaluate that at x equal to 1. So I have minus 1 over root 2 pi. And then that's going to be equal to e to the power of minus a half times 1 is just minus a half. Well, that will always be negative, right? That is negative because e to the power of minus a half, well, that's just 1 over root e. So I have minus 1 over 2 pi times positive 1 over root e, and that is going to be less than 0. So, like, true. Right, let's have a look at another one here. Let the function f of x be 8x plus sine 4x plus 4 sine 2x. Find the first derivative. So we're dealing with trig functions here. So that is 8 plus sine goes to cosine, and I multiply by the derivative of the angle, which is 4. So this goes to 4 cosine 4x. And then this will go to 4 times 2 is 8 cosine 2x. Now I need to write f of x in terms of cosine 2x. So I need to now get rid of this cosine 4x. So we're going to use a trig identity here. We're going to be using the identity. So cosine 2 of an angle is equal to cosine squared of that angle minus sine squared of that angle. So if I say here 2a is equal to 4x, a is equal to 2x. So I can rewrite cosine 4x as cosine squared 2x minus sine 2x. So 8 plus 4 times cosine squared cosine 2x minus sine squared 2x plus 8 cosine 2x. Now I need to get rid of this sine squared. Well, you remember here, cosine squared plus sine squared is equal to 1. Therefore, sine squared equals 1 minus cosine squared. So this here will become 1 minus cosine 2x. So minus 1 minus negative cosine squared, that'll be plus cosine squared 2x. So I'm left with here 8 plus cosine squared 2x plus cosine squared 2x is 2 cosine squared 2x times by 4, 8 cosine squared 2x. 4 times minus 1 is minus 4 plus 8 cosine 2x. Therefore, my answer is 8 cosine 2x 8 cosine 2x plus 8 cosine 2x. Then 8 minus 4 is 4. That is my first derivative there. And then finally, what I'm asked to do here is prove that it's increasing for all values. So I know I'm kind of left with a quadratic here, so I'm just going to say for the minute y equals cosine squared, oh sorry, 2x, right? 2x, because I'm just not, that's the 2x up here. Because as you can see, it just gets messy when I keep writing out that. So I have 8y squared plus 8y plus 4. And I want to prove that's greater than 0. I could divide across by 4 here. I have 2y squared plus 2y plus 1 greater than 0. Okay, so now I'm kind of dealing now with, I need to prove that my left-hand side is increasing. There's no way for me to factorize this. So I'm going to complete the square. If I complete the square here now, so factor out of 2, I'm left with y squared plus y plus a half. Half the middle coefficient and square it. So that would be a half squared, which is a quarter. 2 times y squared plus y plus a quarter plus a half minus a quarter. This will break down to, or factorize to y plus a half squared, and then a half minus a quarter is a quarter. Multiplying that 2, I'm left with 2 times y plus a half squared, 2 times a quarter, which is a half. And then we know, I said y is equal to this, cosine squared 2x. So, oh, sorry, y is just equal to cosine 2x, not squared. 2 times cosine 2x plus a half, squared plus a half greater than 0. Well, yes, because this here will always be positive because anything squared is positive, and I'm timesing it by 2, and the half is greater than 0, so that's positive. Therefore, it will always be positive. Right, and that is the video on increase and decrease points. I hope this video was somewhat helpful to you guys, and I'll catch you guys later. Bye.